What if I told you your TI-84 could simplify radicals the exact same way you do on paper, and maybe even faster? Today we're going to build a program from scratch that simplifies square roots using the largest perfect square method. Not only will this help you check your work, it will actually reinforce how radical simplification works. By the end of this video, your calculator won't just compute answers, you'll understand the math behind it. Before we touch the calculator, let's review the math. So if I simplify a radical like the square root of 72, I look at all of the perfect squares and I see which ones that will divide into 72. Well, 1, 4, 9, and 36 all divide into 72, but I always use the largest perfect square, so we will choose this one. So that the square root of 72 is equal to the square root of 36 times 2. Alright, so the square root of 36 is 6. Square root of 2. So here we simplified the radical square root of 72 into 6 square roots of 2. Okay, now let's write our program, and we'll use the same logic that we used when doing it by hand. Alright, so let's go ahead and create a program. So I'm going to go down to the program key, go to New, Create New, and let's give it a name. Okay, I'm going to turn my alphanumeric on, and I'm going to call mine SIMPRAD. Alright, so the first few things we want to do is we want to clear the screen and let's define some variables. So if I go to Program, Input Output, number 8, I clear the screen. Okay, I'm going to create a label which is like a reference point in the code. So I'm going to go to Program, number 9, Label. I'm going to call this Label 1. It's at the beginning. Okay, I'm going to store 0 to some variables. So I'm going to say 0, STO store. I'm going to store 0 to A. That's alpha A. 0 store. I'm going to store 0 to B. And I'm going to store 0 store to letter N. Okay, now I'm going to display something on the screen. I go to Program, Input Output, number 3 is Display. And I'm going to tell it to display something like simplify radical. Press Enter. Okay, now I want to input something. So I'm going to go Program, Input Output. Number 1 is Input. Turn in my alpha, doing a quote. And let's say enter radicand. And let's put a colon there. Okay, I'm going to end my quotes. I'm going to turn this alphanumeric off, comma, and I'm going to choose the letter N, so alpha N. Press Enter. Okay, so let's do some logic. If N, if it's less than or equal to 0, then we don't want that answer. So how do I get a less than or equal sign? I go to test, which is I go second math. Number 6 is less than or equal to 0. Press enter. Then press enter. I want to display, hey, you messed up, okay? So display, go to input output number 3. Okay, so I'm turn this alphanumeric on. I want to display number must be positive. I'm going to run out of room. I'm going to start another line. Alright, take that letter out there. Alright. Display again. Positive. There we go. Okay, so let's go ahead and stop. Okay, so stop. I'm going to start from the bottom and go up. It's probably nearer. There it is, G. And then I want to end. There's N is number 7. Okay, let's put this in a loop. So program number 4 is 4. Okay, I'm going to have a counter. I'm going to call this counter I. So alpha I, comma, I want an integer sign. So for an integer, I go math, number 5 is integer. I want the square root of n. So I will go second x squared, that's the square root of n, alphanumeric n, close parentheses, twice, comma 1, comma 1, close parentheses. Okay, if the fractional part, so to get the fractional part, I go math, number. So fractional part is number 4. So if the fractional part n divided by I squared. Okay, so I'm going to go I'll go caret, I guess. I squared, close parentheses twice, equals 0. So I go second math equals 0. And press enter. Then you notice what I'm doing is I'm counting backwards. Instead of counting at 1 and going up, I'm starting at the upper limit and going down. That means the first instance I get where I have a perfect square dividing it into the number, it'll just drop out of the loop. So that's what we're doing here. So then I'm going to store I to A. So let's store that to variable A, like this. Let's say then that n divided by, open parentheses, I squared let's store that to B. Now if I was doing cube roots, instead of these 2's here, I just put 3's. Then that would give me the cube root of a number. But we're just going to keep it simple here. Okay, let's go somewhere now. So let's go to. Alright, so I'm going to start at the bottom and go up because it's probably closer. There it is. So go to. Let's go to routine number 2. And let's end where we're at. Program. Number 7. Let's do it again. Program. Number 7. Okay, so let's write section number 2. Says program, label, which is 9. And this is label 2. There's clear the screen. Be number 8. This display. Turn my alphanumeric on. I'll type the word result. Okay, if B is 1, test, if B equals 1, then we'll simply display A. Okay, we'll tell it to pause. Which is number 8. And while it's pausing, let's put a little message up there. So I'm going to turn my alphanumeric on. Press enter. So the calculator is just going to sit there and wait for you. All right, let's go to let's go to 5, else. You may or may not have it on your calculator. If you do not, I'll show you another way of doing it later on. If you have a fairly new operating system, you should have this command. Okay, it's called toString. So if I go to Program, Input, Output, it's a new one, so it's going to be near the bottom. So I'm going to start at the bottom and go up. There it is. toString A. So what it's going to do is it's going to take the number A and convert it into a string. Plus, okay, I'm going to put a quote there and then a square root sign. Then another quote. Plus, I'm going to do toString again. I'm going to convert B into a string. All right, let's close that. Plus, I'm going to go quote parenthesis, close, and another quote. So I'm going to make a kind of a pretty little answer here. I want to store this, but I want to store it as a string. So I have to go to vars, to number 7, and I'm going to choose string 1. So I'm going to save this in a pre-built variable called string 1. And press enter. Now I want to display my answer, so I go to Program, Display, and I want to display string 1. So that's vars, number 7, string 1, press enter. I want my answer to sit there, so I'm going to go Program. I went to pause. I'm going to tell it to press enter. I'm going to tell it to go to 5. Let's end this. Program number 7, end. Okay, let's write routine 5. I'll skip a line. So I go to Program number 9, label 5. So let's clear the screen. Input output number 8. Let's do a menu. So I go to Program Controls, Menus near the bottom. So I'm going to go up there. Oops, too many. And I want to say, ask you, do you want to do this again? Comma. Oops, turn it off. Comma. If so, I want it to be yes. Okay. Yes. End quote. Comma 1. Store 1 to it. That means it goes back to label 1 if it do. Comma. And if you want no, you do not want to do this again. I'm going to go to number 9. Okay, let's stop. Okay, where's stop? And let's end. Label 9. So this program number 9. You don't have to do this, but it's good practice. Let's delete the variables that we just created. So I'll delete variable A. I want to delete variable B. And I'll delete variable N. And let's be nice and clear the screen again. And we'll stop and end. Okay, if we didn't make any mistakes, then we're okay. Alright, again, I haven't forgotten, I'll show you in a few minutes after we test this program. We probably have mistakes all over the place, so let's just check and see. So I'm going to go second quit. Let's go to Programs. Let's execute the program. Alright, so let's do 72. That's what we did by hand. Okay. I have a mistake somewhere. Let's see if we can find it. Alright. Let's go to Program, Edit. Alright, let's check my math here. I found my mistake. It's right here. I forgot to put a negative sign in front of my 1 there because I wanted to step back 1 each time. So if you go back and change that to a -1, everything else seems to check out okay. Second quit. I go to Program, execute the program. So if I go back to the 72 that we did, it will give us 6 square root of 2. If I want to do something like 50, 5 square root of 2. If I do something with a perfect square, it's just going to say 8. And suppose I want something like 17. Okay, so there we go. And like that, your calculator now simplifies radicals the same way you would on paper. Notice something important. It didn't guess. It searched for the largest perfect square factor. That's exactly the mathematical thinking that we want to develop. In a future lesson, we're going to expand this tool. What if we could simplify cube roots? Or radicals with variables, like square root of 12 times x squared, or maybe even fractions? Who knows? But the next one will be much more complicated and much more robust than this one. Alright, thank you for watching. Please subscribe if you haven't done so, and like the video. It means a lot to the channel. So see you soon with another instructional video. Goodbye. If your calculator doesn't have the function toString command, then substitute display A, comma, quote, square root sign, end quote, comma, B. Now this will break it up into 3 lines, so your answer is going to cover 3 lines. The 2 numbers will be justified on one side, and the square root will be justified on the other side. But unless you want to play with output commands, this is the simplest way of achieving the answer on the screen.